Hello everyone, welcome to the Math Bender. This is Adnan Zedi, and today we'll talk about quadratics inequalities. Let's start. Okay, so before starting off, we need to know what an inequality is. So any mathematical inequality that represents with the sign like these, greater than equals to, less than equals to, or not equals to. Since they are not equating with each other, so hence they are called inequalities. Okay, and when we talk about quadratic inequality, so let's see a quadratic curve, how it could be. So there are two types of quadratic curves, a smiley face and a sad face. So let's say if this is a function f of x, which has as any random equation, and these 2 points are a and b. Now, and this is as well a and b, and this is some other function which is g of x. So a quadratic curve, we can say that at a and b, when x is equals to a and b, f of x, the function, is equals to 0. When we say function, we mean y values are 0. As you could know that the coordinate is going to be b comma 0 when the value of x is this, and a comma 0 when you write it like that. So at a and at b, when x is a and x is b, the curve reaches 0. And when we talk about curve, we talk about function, we talk about y value, but x values are specifically we name as x equals to. But let's see this region, so the one highlighting right now. As you could see that this is below the x-axis and it is negative, so we can say f of x is less than 0 when the values of x are between a and b. So as you could see, at a it was 0, and as it was moving to the right, the x values, the curve went down, and so on until it reached b. So you can say when a is less than, x is less than b. Since it's a continued inequality, that's why we write it like that. This means as same as between a and b. And then if we highlight this region and this one, as you could see, the curve is above the x-axis and it is positive. So we can say f of x is greater than 0 when x is less than a. Since x is less than a and x is greater than b. So when x is more than the value of x, which is b, and x, when it is less than a, the curve was above the x-axis and it was positive. This is all about inequalities you need to know. It's just that the shape of the curve changes. For example, in this scenario, you can say f of g of x, since it's the name of this curve is g of x is equals to 0 when x is a and x is equals to b. Same as g of x is less than 0, so highlight that. So less than 0, as you could see that this is below the line, when the value of x is moving to the right and value of x moving to the left of a. So you can say when x is less than a and x is greater than b. You need to sketch the curve before in order to understand it completely. And same goes, g of x is greater than 0 when a is less than x is less than b, means between a and b. If I highlight in that, this is going to be this one. As you could see, the curve is above the line. So this is a basic idea how an inequality or quadratic inequality may look like. So let's move forward and check some of the different type of functions that I've drawn already. So let's say this is f of x, any function, and I've drawn just some random graphs here and taking it out. So if I say f of x is equals to 0, you can see the function does not have a value where y is 0. You will write no solutions. Not possible. You can also write not possible. But if I say f of x is greater than 0, as you could see, the whole entire curve is above the x-axis and greater than 0. You will say all values of x. The function is positive for all values of x. Or another way we write it, x belongs to real number, means all values of x. We just write it like that. The third is f of x less than 0, and this means that the curve below the x-axis, you could see that the curve is not even anywhere below the x-axis, so we write no solutions, which means there are no values of x for which the curve went below the line. Next thing, if I see this one and I can say f of x equals to 0, as you could see that the curve is equal to 0 when x is equals to 2. That's it. And if I say f of x greater than 0, now as you could see, the curve is entirely above greater than 0, above the x-axis. It's just that it is touching 0 at x is equals to 2. So all the values of x are applicable in this situation except the value when x was 2, because when x was 2, the curve was not greater than 0, but the curve was equal to 0. So you write it, x belongs to real number, means all values of x, and then x is not equals to 2. This whole answer will cater to the inequality that was written, and you need to mention that as well. But if I say f of x greater and equal to 0, now this means that you write down all the values of x for which the curve was either equal to 0 or greater than as well. So you write x belongs to real number. Then you don't need to write this value there. The reason being that x was equal to 0 when x was the function was equals to 0 when x was equals to 2, and this also caters to that because greater and equal to 0. Then the last one is f of x less than 0. Now you can say that no solutions. The function did not go beyond the x-axis, below the x-axis. No solutions. There are no values of x for which the curve went below the line. Now these ones. So if I say f of x equals to 0, then I could write it as x is equals to 3 and x is equals to minus 2. And if I say f of x greater than 0, now this means write down all the values of x for which the curve was above the x-axis, not even touching the x-axis. So these are the values. This is where the curve is. So you can say it is greater when x is less than negative 2 and x is greater than 3. If I say f of x greater or equal to 0, so which means it is greater as well as touching the x-axis or equal to 0. So you write x is less than equals to negative 2 and x is greater or equals to 3. Now this means that the curve was 0 at negative 2, but it was positive as well when the values were less than negative 2. So all the inequality will cater to the function greater or equal to 0. If I say f of x less than 0, this means that the curve, this region, so negative 2 is less than x is less than 3. It's just that if I add a less than or equals to here, it will be less than or equals to here as well. Now looking at another part of it. Now x is, I can say f of x equals to 0. You could clearly see x is equals to -2 and x is equals to 3. Now if I say f of x greater than 0, then it's straight, this is the one that is greater than 0. So I can say the values between -2 and 3. So -2 is less than x is less than 3, for which the function is greater than 0. If I say f of x is greater and equals to 0, the inequality only will be the same. It's just that the value of -2 and 3 will be a part of the answer, because at -2 and at x is equals to 3, the curve was curve equal to 0, and inequality means that f of x is greater and equals to. So write down all the values of x for which the curve was either greater or equals to as well. And the last part is f of x less than 0. So if I say less than 0, then we could highlight this one and this one. So this is going to be x is less than -2 and x is greater than 3. For f of x less than or equals to 0, it's going to be x is less than or equals to -2 and x is greater than or equals to 3. So this is just basic prototype of how the curve may look like and how the inequality may react to it. Let's look at some of the questions here. Now, if we have a question like this, where we have 2x plus 3 times with x minus 5 is less than 0. Step 1, find out the roots of it. So 2x plus 3 times x minus 5, make it equal to 0 first and solve it. So you know that 2x plus 3 equals to 0 and x minus 5 equals to 0, the way we approach a quadratic solution. X is equals to -3/2 and x is equals to 5. Now you found out the roots. Now sketch the curve. Since squared term is going to be positive, it's going to be a smiley face. The roots are going to be -3/2 and 5. The curve wants you to find out the values for which the curve is less than 0. So the curve is less than 0 between these two. So you write -3/2 is less than x is less than 5. So the values of x between -3/2 and 5, the curve will be entirely below the x-axis or negative or less than 0. Let's look at this curve here. So if I write x minus 5 whole squared greater than or equals to 0, and I solve it. So first step, x minus 5 is equals to 0 whole squared, and x minus 5, if you take root both sides, will be equals to 0. X is equals to 5. There's only one solution, which means this is the turning point of the curve, and it's going to be a smiley face, as the curve has only one root and x squared term will be positive, where this value here is going to be 5, 0. Now wants you to write down greater and equals to 0. Can you see that it is exactly this situation? So they want you to find out the values of x for which the curve were either 0 or greater than 0. So you write x belongs to real number, all values of x, because the curve was 0 at x is equals to 5. For all the values of x, the curve was greater than 0. So let's look at some other questions. So we have a quadratic equation like this in this format. So x squared plus 5x minus 14 is less than 0. Okay, now so you have to, so you know how to solve quadratic equation by completing the square by quadratic formula and by breaking the middle term. So first step is x squared plus 5x minus 14 equated with 0. Find out the values where the curve is equals to 0. So if I solve it, x squared plus 7x minus 2x minus 14 equals to 0. X taken common, x plus 7 minus 2, x plus 7 equals to 0. So x plus 7 times x minus 2 equals to 0. X is equals to negative 7 and x is equals to 2. So when you sketch this, it's going to be a smiley face because x squared term was positive and one of the root is negative 7 and the other root is 2. Now you are to find out less than 0. So less than 0, the curve is less than 0 here. As you could see, this is less than 0 below the line. So what are the values of x for which this curve was less than 0? And you can straight away write down as negative 7 is less than x is less than 2. These were the values of x for which the curve was below the line or less than 0. One more question I'll try to solve here. Since normally last questions are the toughest ones, so I'll take this. But if you have any further queries related to that, you may write in comments and I'll try to approach back. Okay, so step 1, same thing, 5x squared plus 9x plus 4 equals to 0. And I'll take a alternate approach and I'll try to solve it using the calculator. So x turns out to be negative 4 over 5 and x is equals to negative 1. So sketching this, greater than 0 means above the 0. So find the values of x for which this curve is above the x-axis. So you can say x is less than negative 1 and x is greater than negative 4 over 5 for which the curve was entirely above the x-axis. This was it about quadratic inequalities. Please do write your feedback, how you like the video. I will discuss more complex inequalities related to quadratic in my next session. Until then, take care. Bye bye.